All right, hello. Welcome to another problem QA review set. Today we'll be going over Coding Club Set 1. So let's start. Question 1. John has the following problem. S is a string of 0 and 1 having a size n. Any ith character of the string forms a triplet, and then its corresponding decimal, known as the rule mean term, are I. And yeah, this changes according to this formula. An example, let's say we have 0, 1, 1, 0, 1. So we split it up with those binary digits. And then we calculate our 0 by, we kind of circle back to the end plus the 0th element plus the first element, which gives us 101, which is the binary form of 5. And we keep doing this for every single digit. And eventually we combine all those digits into a number. So it looks like they want us to write a function which takes the string and prints this out. So let's skip on ahead to the example that John here has attempted. So we have the array of size 3, and we go through the entire array. And then we have several cases, right? If I is 0, then we want to make sure we get the last element plus 0th plus first element. So the logic here looks kind of correct in that sense. And then the else statement is the edge case where if I is at the very last, then we want the char at I minus 1, and then the I current, and then I 0. And then else, we just do the standard I minus 1, I, and I plus 1. And then lastly, we get those integers, which are either, 0 or 1. And we convert that into its decimal version. So upon first glance, this looks pretty correct because we're correctly handling the edge cases. And then we're storing that in an integer array. But one thing that stands out that could throw the question off is to keep in mind that John declared the array as an integer array, whereas it's filled with the string s as characters. So what that basically means is that this array here, it's not really containing 0 or 1 as we expect, such as in here, but because we're creating integers using chars, right? And remember from our last lesson, when we do things like that, we actually end up with the ASCII value of that char rather than the char itself. So what will end up happening is it'll contain the ASCII values of 0 and 1 instead of 0 and 1 themselves. And if you look at the ASCII chart, that'll end up being 48 for 0 and 49 for 1. So because of that, the answer here would be A, because the way that we convert it to decimal, John here is assuming that array at J is some sort of 0 or 1 binary digit, but is not actually that. It is end up 48 or 49, which is the ASCII representation of that. So a way to fix this would either be to change how we store the digits in the array itself, or we change how we convert that into the decimal version. And if you want to change how we convert that, we would have to take the ASCII value and then find the corresponding value of that ASCII character and then perform the operation. So with that being said, the answer here is A. This line right here. All right, so next question, Shyam, a student has n number of subjects for his class. He wants to check in which subject he has got the second highest number. For this, he has written a code like the following. Okay, so we have, he looks like he created a function called find max that loops through the entire array, and he keeps a storing of the max, and he checks each time if that element in the current element in the array is greater than max, then we jot that down and we keep track of max. and we keep track of that position. So now back in main, after all these this kind of just gathering info code, we set the memory allocation, everything. We take in the input, and then he calls he creates a variable called position of higher number equals find max. So this should be the max value based off of this function here. And then he sets that to int min. So he finds the highest integer in the array, or more specifically, he finds the index of the highest number and he sets that to the lowest integer. And then he calls pos of higher number again. So it looks like this is correct in what he's trying to do, which is find the second highest number. So let's look at the question. On the basis of the code, which of the following statement is true? Code will never yield a desired result. I mean, that's false. I mean, from the looks of it, he's finding the second highest by kind of just eliminating the highest and then calling the highest again. The code will yield the desired result, but it alters the original marks. That is true, because remember, we are getting the second highest, but in doing so, we're setting the highest number to integer min. So the array itself will end up slightly altered. Because of that, we can't really say the code's perfect because it's a kind of a side effect of what we're doing. And there's no runtime error happening here. So answer is B. All right, question 3. Alice has been given an array of digits 1 to 9, and her task is to find the minimum possible sum of two numbers formed from digits of the array. All digits of the given array must be utilized exactly once to form the two addendums. So we have the code here, and it looks like this is the classic bubble sort algorithm where we loop through every single pair within the array, and then if a pair is mismatched, as in if the left side ends up greater than the right one, then we swap them, and we do that with the big O notation of n squared. So this is classic bubble sort, and it'll end up sorting the array. And then here, so in the solve function, she first sorts it with that bubble sort, so that's good. And then loops through the array, and then if I and 1, then we multiply, else they would do b times 10. So first a is a times 10, and else b equals b times 10. And then here's the main, which is just gathers the info. So in the above code, what is the meaning of the commented line? So what is if I and 1? So in C++, we deal with very much more lower level computations than other languages such as Java. So in this case, we're asking if I and 1. So now we're going to be diving into kind of using bitwise operations and to determine what the value of this is. And the AND operator, again, is a bitwise operation. So we know that we're going to do bitwise operations. So I is just a number, so 0, 1, 2, 3, etc. So let's just say I is, let's just say I is this. The AND operator pretty much forces it into an AND comparison. And then 1 is just the binary 1. So 0, 1. And remember, if we're going to do and if we're comparing bits with and, then we check if both of these are true. So 1, 1 are both there. So that is going to be true. So because of that, the answer here is going to be D. It's when odd. Why is it only checking when odd? Well, if we compare something and we compare it against 1, we're basically asking if the least significant bit, which is the bit on the very most right side, we AND it with that. And if we AND it with 1, then we know that we're only going to be focusing on the least significant bit. And if it's odd, if the number itself is odd on the top here, then we know it's always going to be true, because 1 and 1 is always going to be true. Now, if we have some even number, and remember, even numbers in binaries will always end in 0. So we could have a bunch of whatevers, but in the end, we have 0, right? So if we AND it with 1 there, then it will be false because we need both, which is false because we need both of these to be true. So this is kind of a neat little trick that we can use to determine if a number is odd or even, like using the bitwise operators. So answer here is D. Question 4. Eddie is given an array of integers where each element of the array represents the max number of hops that can be made forward from that element. Eddie's task is to find the minimum number of hops to reach the end of the array starting from the first element. If an element is 0, it cannot move through that element. Output should be the minimum number of hops to get out of that array, or -1 if getting out of the array is not possible. So let's go through the code a little bit here. So we have the classic just scanf, getting the array. We're allocating the memory for that array. And then we're going to be populating that array using user input. And then we're going to be calculating min jumps here. And if the response ends up being integer max, then we know that there is no possible way to get to that end value. There's no possible number of jumps, so that's -1. Otherwise, we want to print out that response. So because this is a multiple choice, let's first take notice on what is different about each of these options so we can kind of narrow down what we're looking for. So it looks like in here, the return value of the base case is different. And here, if the start and end is equal, in this one, it returns 0, but the rest of them, or in this one, it returns int max, and this is also 0. So now we ask ourselves, what kind of base case are we looking for? So if you remember back in the header, we have the array itself, and then we have the start and the end. And since this is recursive, since this method is recursive, our goal, our general direction of what we're trying to achieve will be to start at the end and then perform some sort of hops to reach that end. Okay. So if we look here, if the start equals the end, then it basically means that we have found a way to reach that end. And the start, it means that we're at the end already. So there's no hops required to get there because we're already there. So because of that, we know that the base case, if Q equals P, if the start equals the end, then there's no hops required and thus requires 0 hops. So because of that, we can eliminate B because B is saying that if we're at the end, then we're returning the max, which is kind of the opposite of what we want. We want to return the 0, not the int max. So B is out of the question. So then now we look at the difference between A and C. So looking through this code, we can see that the main difference here is how we declare int min, which is kind of the way that we calculate the min number of hops before each recursive call. So in option A, we set min to the integer max. In option C, we set min to 0. Now, if you remember anything about calculating the max or min of anything, right, whether that's recursive or not, you always want to set the starting variable of that as kind of the opposite so that you could always find a better option as you go along. For example, if I'm finding the minimum value in a list, I want to start off the max with just the maximum value so that I could find my way down to that minimum. In a similar case here, we want to set the min to max because, well, if we set it to 0, then we're never going to be able to find a better min, and it'll essentially just nullify the entire algorithm. We want to set min to max here. So because of that, the answer will be A. All right, let's go on to question 5. Given an array of size n that has the following specifications, So each element in the array is either represented by a thief or a police, which is T and P. The policeman only catches one thief, and the policeman cannot catch a thief who's more than K units away. So it seems like the policemen have some sort of range represented by K. And we want to find the maximum number of thieves that can be caught. So let's look at this pseudocode algorithm here. So we have N, which is the array. K represents the range that each policeman has. And then the array is array of size N is just the list of policemen and thieves. So for each element, we go through, so this is just saying we go through the entire array. If we land on a P, which is policeman, then we go to step 4, which is we search the range of that policeman for any thieves. So we check whether array at Z equals T. And if yes, then we increment X. So it looks like X is going to be our counter for number of thieves that can be caught. And then we kind of loop back to 2 again and repeat that for every single time. So it looks like the algorithm, what the algorithm is doing, it is sifting through the array. And every time we land on a police, we enter this sub loop, which scans the surroundings of that police. And for every single time we hit a thief within that range, we want to add another counter. So this looks mostly correct, but one key error that's happening here is that we can end up with overlap within the array. So for example, here, let's say we have a policeman here. Let's go like this. Policeman, let's have a thief here, thief, thief, okay? So if we have, let's say, a range of 2, then the policeman will end up catching this, right? So this guy is caught. Now, when we go through to the later part of the algorithm, we're going to hit this police, and we're going to hit, okay, what is 2? We have a range of 2. So we're going to end up going back, catching this guy, and catching this guy, and catching this guy. And if you look here, we're ended up catching this robber twice, which is, we're basically going to be overcounting any thieves caught. So because of that, number 5 is going to be B. Now, a way to fix this is we could possibly add one step in step 4. We could say something like, you know, if we end up catching a thief, then we can mark that down so that when we go to another police, we don't end up overcounting that. So we can say something like RZ equals, you know, we can say something like C to pretty much mark that as a caught thief. All right, let's go to question 6. Akash, an intelligent boy, has been challenged by his friend, and it goes the following. A string of numbers is given to you, and also you are asked to do a plus and time sign between any 2 numbers. Find the maximum value from that string. Okay, so it looks like we have a sequence of chars representing numbers, and we want to figure out what the most optimal highest number we can achieve by inserting either additions or multiplications between each number. So he starts off with res, which is our return value, and we start at 1 and we go through the entire sequence of chars. And it looks like we got the general logic down, because if we hit 0 or 1, it would be better to add, because we're either adding 0 or adding 1, which beats multiplying by 0 or multiplying by 1. So it looks like we got that core logic down. But it says the code is not offering correct results. And the error here is somewhere in this line. So what line change would fix this? And now one key thing to remember here is that another edge case that we have to consider is if res equals 1 or if res equals 2, okay? Let's say res equals 1. If res equals 1, then we still want to add 0 or add 1 rather than multiply. Or let's say res is 1, but then the str ends up being some high number, like 5 or 6. Adding 1 times 5 is not as good as 1 plus 5. 1 plus 5 is 6, but 1 times 5, it'll still keep it. And same thing if res equals 0. If res equals 0, we want to add the value. We don't want to multiply. Okay. So because of that, another check that we have to make sure is if res is less than 2, or if res equals 1 or 0. And so like we need to add that as another or condition on this line right here. So because of that, our answer here is A. Okay, question 7. Mary is trying to place n number of queens into a chessboard of n rows and n columns. She writes a program so that she could know the possible number of such placements for any given n. For this, she writes the code below. So this is kind of a big question here. So let's go through this. So we have main where we just populate the board, and then we call n queen, which is looks to be the algorithm that she uses. We have void init board, which just fills the board up with x's, so it just initializes the board. And then n queen, which is a very big recursive method here. We have our base cases where if cur row and start call is equal to size, then we exit. And then looks like we recursively go down if the start call, if we reach the end of the size of the board for the columns. We have the method called erase queen. Let's go inside there. So looks like erase queen, what it essentially does is it loops through each of the columns on the board. And if it reaches a queen, then we want to essentially erase that queen and just instantly return that column. So erase queen, it just, like given a row, it'll erase the first occurrence of a queen on that row and then return the column on which that happened. We also have a method called feasible here, which looks like we go through the board in a double for loop, and we return 1 if there is a queen on that board, or if there's a queen on that row and call. Otherwise, return 0. And looks like the logic here is if I is row, so if it equals, and also if the absolute value, so it eliminates any negatives of I minus row or j minus call. And lastly, we have show board here, which just prints out the contents of the board. Now let's go back to n queen here. So we have this first recursive call, and then here is the meat of the function where we sift through the columns and we check if for each column, if the row at that column is feasible, which is saying if it's doesn't contain a queen, if it's kind of empty, then we want to add a queen to that. And if we're at the last part of the row, then we want to print out the row and increment count and add an x there and increment count by 1. Otherwise, if we're not at the very last row, then we want to recursively call n queen and just add the row. So we're kind of just going through the entire row 1 by 1. Else count plus 1. And then here's the commented part where if count equals size minus the start column, then we want to find the previous queen column and erase that, and then recursively call n queen on that previous row. So the question here is, which of the following interpretations is valid? Okay, so let's look back to this here. Remember, if count equals size minus start column, then we want to erase the queen on that previous row and then recursively call it on that previous row. So the answer here is going to be B. If one cannot place a queen in any of the columns of the current row, then go to the previous row, which again, this is what's happening. It's going to that previous row and recursively calling it. erase the queen, which again is what's happening here. We're calling erase queen on that previous row. Erase the queen and get the column number of the queen placed in the previous row. Try to put the queen in the previous row starting from the next column where the queen was placed previously. And we can see this exactly playing out here because again, we're keeping track of that column and we're erasing it and then recursively going down on that column. So this is kind of a big method here, but if you trace through it and go through, you'll see that exactly what's happening is what's being described in B. All right, number 8. Satya, a student of mathematics, was given a set of n matrices to be multiplied. Satya was curious to know that out of different ways of multiplying all these n matrices, which one could yield a minimum number of scalar multiplication? Okay, so for example, if we have a 10 by 100 and a 100 by 5 and a 5 by 50, there are two ways that we can multiply this. We could find the dot product of the first two, x and y, and then dot product that with z, or we could do the other way where we find y and z, find the dot product of that, and then dot product that with the original x. And the algorithm that we wish to do is figure out which way of this, we're going to handle all these cases and then figure out which is the minimum number of multiplications that we can do. So in this case, the first way, we find the dot product of x and y, the 10 by 100 and the 100 by 5. So if we find the dot product of the first x and y, we end up with p here, which is 10 by 5. Because if you remember the dot product rule, we find the lower of the x and the lower of the second part, and we combine that together. So that becomes 10 and 5. Now, if you find the dot product of, so we now have p, which is a 10 by 5 matrices, and then z, which is still here, 5 by 50. And now let's count up how many scalar multiplications happened in order for this to happen. So when we multiplied, or rather when we found the dot product of x and y, we found, so it would be x times 100 times 5, which is the second part of y. And then we had to do the same thing on the other side. So 10 times 5 times 50. So 10, 105, and then 10, 5, 50. So we have 5,000. And then to multiply this 10 by 5 with a 5 by 50, we do the same thing. So we get 10, 5, which is the first part, and then the second part of the second one, which is 10, 5, 50, which is 2,500. So this is kind of the general way to count the number of scalar multiplications when you find a dot product of matrices. And looks like Satya here wants to kind of find out how to turn that into a code so that we could, multiply, we can automate this whole thing. So the given code that she started out with seems pretty simple, where we just we have a compute, which is going to be a recursive function. And then we if start, so we have a start and end. We're going to keep track of two variables here. And of course, if they're at the end, then we want to return. Otherwise, we want to go through from the start into the end, and then we count the number of scalar multiplications that happen, and then set the min count. So this question is a little complicated because it's going to involve a lot of math, but the answer here is going to be B. And the reason for this is because the chain of matrices must be split in every possible place. And then for that split, the scalar multiplication should be computed recursively before and after the split. So in a particular iteration, the recursive function should be called first from start to iteration position, and then from next iteration position up till n. So if you look at option A here, we're going to have, if we recursively compute start to end, then we're not essentially doing anything. We want to keep track of iter here. So we can iterate through every single possible slice of multiplication. So we have compute here, and then we have compute again. Dim array, we increase iter by 1, n. And then again, this part remains the same. So option here, the answer here would be B. All right, almost there. So we have question 9. What does the function do? So we have a number and we use a stack. So if you remember what a stack is we pretty much, when we start elements in the stack, it's first in and then last out. So if you start an element, let's say 2 here, you can think of it as like an actual stack. If we insert 3, then we have kind of, can think of it like an actual stack where 3 goes on top. And then if we want to extract the elements, we have to do it last out. So the extracted elements will happen in reverse order. It will be 3 and then 2. So that's a quick recap on what a stack is. So it looks like we're having, while a number is greater than 0, we're going to push the modulus of that number and then divide it by 2. So remember, if you find the modulus of 2, then we're basically determining if it's going to be 0. So if the number is even, then we're going to print out 0. And if the number is odd, then the modulus 2 is going to be 1. So it looks like we're going to be doing something with converting something into binary, right? So like, for example, if we have, 50, the modulus of 50 is going to be 0. And then we divide 50 divided by 2 is 25. And then, so we're going to push 0. And now we find the modulus of 2, or the modulus of 25 modulus 2, which is going to be 1 because 25 is an odd number. So now we push 1 on top and divide it by 2 again. So 25 divided by 2 is going to be 12. It's an integer. And again, 12 modulus 2 is going to be 0. 12 divided by 2 is 6. 6 modulus 2 is going to be 0 again. So we're going to be repeating this whole process, which is essentially we're going to be converting a decimal into binary. So with that in mind, we can see that the answer is going to be B. All right, last question here. Following is the pseudocode for matching a pattern within a string. Find the missing statement. So we have integer m, which is a pattern, and n, which is the entire text. And it looks like what this is attempting to do is find the pattern within the text. So we have a for loop going from 0 all the way to n minus m. And we do this because we don't want to go out of bounds. And then we have another for loop inner that goes from j equals 0 all the way to m, which is the pattern. If the text of I plus j is not equal to j, then we end for. So looks like right here, the thing that we want to fill this in with is going to be a break. So why is this? It's because if the text of I plus j, which again is the text of the current text that we're iterating, if that's not the pattern, then when we want to break out of this for loop and back into the original for loop. So because of that, the answer here will be B, break. Continue wouldn't make sense because we're still in the loop anyway, so that can't be it. And exit is not a Java command at all, so it can't be exit. There is system.exit, or not Java, it's C++, but in this case, it will not be exit. And then it's not none of this because we concluded that a break statement would be needed on this line. So for that reason, we have B as the final answer. All right, so that'll conclude the 10 questions for this. Remember, this is coding club. This is the set 1. We also keep in mind that we have a website, as well as a YouTube, which we will be uploading videos like this. So please check us out. Thank you.